Hello students, this is Dilip Udhani and today I will teach you a new unit, that is series solution of ordinary differential equation and special functions. So in this unit we will understand the solution of differential equation using Frobenius method. We have already discussed the series solution of a given differential equation about an ordinary point. So in this lecture I will make you understand the series solution of differential equation near a regular singular point. So this is an extension of power series method. It is also called Frobenius method or generalized power series method. So let R1 and R2 are the roots of the initial equation. Now what is initial equation? I will make you understand this with the help of one example. So we have total three cases. Case number 1, distinct roots not differing by an integer. We have three cases based on values of R1 and R2. And case number 1 is when the values of R1 and R2 are different, but their difference is not an integer. So in this case, the general solution is given by the formula y equals to c1 y1 plus c2 y2, where y1 equals to y at r equals to r1 and y2 equals to y at r equals to r2. Now we will see one example based on case number 1. And example number 1 is solve in series the differential equation 4x d square by dx square plus 2 dy by dx plus y equals to 0. So the given differential equation is 4x y double dash plus 2y dash plus y equals to 0. So this is equation number 1. Now comparing this equation with the standard form p0x y double dash plus p1x y dash plus p2x y equals to 0. So by comparison we have p0x equals to 4x. Now for x0 equals to 0, by default we will take a point x0 equals to 0 if it is not defined. So for x0 equals to 0 we have p0x equals to 4 into 0 because the value of x, that is 0. So 4 into 0, the result is 0, right? Therefore x0 equals to 0 is a singular point if p0x equals to 0. Now we will show that x0 equals to 0 is a regular singular point. So for that purpose what we have to do, we have to divide the given differential equation by 4x. So dividing the given differential equation by 4x, we have y double dash plus 2 over 4x. So it will become 1 over 2x into y dash plus 1 over 4x y equals to 0. Now comparing it with the standard form y double dash plus p of x y dash plus q of x y equals to 0, we have p of x equals to 1 over 2x and q of x equals to 1 over 4x. Now we will find two functions. One is x minus x0 p of x and another is x minus x0 whole square q of x. So replace x0 by 0, x as it is. So this will become x minus 0 and p of x is 1 over 2x. So x will cancel out. We have 1 by 2. Now if we will put x equals to 0 in this function, but as you can see that this is a constant function, it will give you the same value at x equals to 0. Now here replace x0 by 0, so we have x minus 0 the whole square and q of x is 1 over 4x. So this is x square divided by 4x. So the result is, after simplification, x by 4. Now this is a function of x, and put x equals to 0 in this function of x, we will get 0. So we have x minus x0 p of x at x equals to 0, that is 1 by 2, and x minus x0 the whole square q of x at x equals to 0, that is 0. So both of these two values are finite values. It means x0 equals to 0 is RSP, regular singular point. Okay, therefore x0 equals to 0 is a regular singular point. Now let the series solution of equation 1 about x0 equals to 0, that is y equals to sigma n is from 0 to infinite an x minus x0 the whole raised to n plus r. Here we will replace x0 by 0. So it will become sigma n equals to 0 to infinite an x raised to n plus r. Now we will separate x raised to n plus r into x raised to n into x raised to r. Now x raised to r will be as it is, and expand an x raised to n. So that will be, if you will just put down first n equals to 0, so it will become a0 into x raised to 0. So that will be a0. Then after plus, as sigma indicates addition, then after 4n equals to 1, second term will become a1 x raised to 1 plus 4n equals to 2 a2 x square plus dash dash dash. Now see, this is equation number 2. Now we will find out derivative of this equation y, that is x raised to r sigma n equals to 0 to infinite an x raised to n. Okay, it means we will consider this form. Now derivative of y is y dash, and derivative of this term will become sigma n equals to 0 to infinite an will be as it is, and derivative of x raised to n plus r, it will be n plus r into x raised to n plus r minus 1. Now again we will find out the derivative of this equation. So derivative of y dash is y double dash, and that is equals to summation or sigma n equals to 0 to infinite an n plus r, and derivative of x raised to n plus r minus 1, it will become n plus r minus 1 into x raised to n plus r minus 1 minus 1, and minus 1 minus 1, and it will become minus 2. Now we will substitute y, y dash and y double dash in equation 1, that is this one. Okay, so 4x will be as it is, then after value of y double dash plus 2 as it is, value of y dash plus value of y. Okay, so you can see over here, okay, 4x as it is. Now this is the value of y double dash plus 2 as it is, and now this is the value of y dash, then after plus, and this is the value of y, that is equals to 0. Now we have to simplify this equation, right? Okay, now see, this is x raised to 1 and this is x raised to n plus r minus 2. So it will become x raised to n plus r minus 1. Okay, then after this term will be as it is, and plus this term will also as it is. Okay, now we will take x raised to n plus r minus 1, then after an and n plus r common from these two terms. We can take 2 common also, right? So sigma n equals to 0 to infinite will be as it is, 2 n plus r, then after an and x raised to n plus r minus 1 common. So in this bracket we will be having 2n plus 2r minus 2, 2n plus 2r minus 2 and plus 1. So minus 2 plus 1, the result is minus 1. So this is the simplification of these two terms. Plus this term will be as it is. Now what we have to do, we have to find out a common factor of x in each term. Okay, so what we will do, we will replace n by n plus 1 in the first term. If we will replace n by n plus 1 in this first term, so power of x will become n plus r. that will be similar to this one. Okay, so we have to make same power of x. So for that purpose we are replacing n by n plus 1 in this term. So replacing n by n plus 1, it will become n plus 1 equals to 0. So we have n equals to minus 1 to infinite. Then after 2, replacing n by n plus 1 plus r as it is. Replacing n by n plus 1, so it will become 2n plus 2 plus 2 are same, and plus 2 minus 1 result is plus 1. And replacing n by n plus 1, we have an plus 1. Then after replacing n by n plus 1, so plus 1 minus 1 will cancel out, so it will become x raised to n plus r, and plus this term will be as it is, and that is equals to 0. Now we have to simplify these two terms, right? So before simplify, we have to see that here the value of n will start from 0, and here it will start from n equals to minus 1. So first of all, we will put the value of n equals to minus 1 in this term, and then after we will start the series from n equals to 0 to infinite. So put the value of n equals to minus 1. So here if you will put n equals to minus 1, so minus 1 plus 1 will cancel out, it will become 0. So r into 2 result is 2r. For n equals to minus 1, it is minus 2. Then after plus 2r plus 1. For n equals to minus 1, we have a 0. And for n equals to minus 1, it will become x raised to r minus 1. Then after write down this whole term, start from summation or sigma n equals to 0 to infinite, plus this term will be as it is, and that is equals to 0. Okay, now 2r into bracket 2r minus 1 into a0 into x raised to r minus 1. This is the first term, and then after we will take x raised to n plus r common from these two terms. So sigma n equals to 0 to infinite, x raised to n plus r common. So into bracket we will be having 2 times into bracket n plus r plus 1 into 2n plus 2r plus 1 into an plus 1, and finally plus an. Okay, and that is equals to 0. Now we will equate the coefficient of lowest degree term to 0, and that will give us an initial equation. Okay, so the lowest degree term is x raised to r minus 1, and its coefficient is this one. Okay, so we will equate this coefficient to 0. So we have 2 into a0 into r into bracket 2r minus 1 equals to 0. But we know that a0 is not equals to 0. So we have r equals to 0 or 2r minus 1 equals to 0. So from that we will be having the value of r, that is equals to 1 by 2. So we can see that here the values of r are different, and their difference is not an integer value. Okay, so we are in case number 1. Now equating the coefficient of x raised to n plus r to 0. So 2 times into bracket n plus r plus 1 into 2n plus 2r plus 1 into an plus 1 plus an equals to 0. And this is true for n greater than or equals to 0, because here sigma start from n equals to 0 to infinite. Okay, now from this equation you have to make subject of an plus 1. So we have an plus 1 equals to minus an and divided by 2 times n plus r plus 1 into bracket 2n plus 2r plus 1. Now say this is equation number 3. So for first solution, what we will do, we will put the value of r equals to 0 in equation number 3. And if we will put down the value of r equals to 0 in equation number 3, it will become n plus 1 equals to minus 1 over 2 into bracket n plus 1 into bracket 2n plus 1, because 2r and r will become 0, and into an, and this is true for n greater than or equals to 0. Now we have to put n equals to 0, 1, 2 and so on values in this equation, right, to find out the values of a1, a2 and so on. So if we'll put down value of n equals to 0, so left hand side will become a1, and this is 0, this is 0, so it will become minus 1 by 2 into a0. So the value of a1 is minus 1 by 2 into a0. Now we will put the value of n equals to 1, so left hand side will become a2, so that is minus 1 over 2, this is 2 plus 1 is 3, sorry, 1 plus 1 is 2, and then after 2 into 1 is 2 and 2 plus 1 is 3, and over here it will become a1. Okay, now minus 1 over 2 2 is 4, 4 3 is 12, and replacing a1 by minus 1 by 2 a0. So minus minus plus 1 1 is 1 into a0 and divided by 12 2 is 24. So we have values of a1 and a2. Now substituting r equals to 0 and values of a1, a2 in equation number 2. Equation number 2, right, that is this one. We will replace r by 0, so it will become x raised to 0, and that is 1. And we will put down the values of a1 and a2. Okay, so the first value a0 will be as it is, minus, this is the value of a1, that is minus half a0 into x, plus this is the value of a2, 1 by 24 a0 x square and so on. Now taking a0 common, so we have into bracket 1 minus x by 2 plus x square by 24 and so on. Okay, so this is the first solution for r equals to 0. Now we will find out the second solution for r equals to 1 by 2. So we will put down the value of r equals to 1 by 2 in equation 3. Equation 3 is this one. We will put down the value of r equals to 1 by 2. Okay, so we have an plus 1 equals to minus 1 over 2 into bracket n plus, this is the value of r, plus 1 by 2 plus 1. Then after 2n plus 2 into 1 by 2, so 2 will cancel out, plus 1 plus 1. Okay, so we have plus 1 into an. Now we have to simplify this result, so it will become minus 1 over 2 into bracket n plus 3 by 2, and this is 2n plus 2 an, where n is greater than or equals to 0. Now putting values of n, that is 0 1 2. Now for n equals to 0, we will be having a1. If we will put down the value of n equals to 0 in this recurrence relation, and if we will simplify the result, you will be having the value of a1, and that is minus 1 by 6 a0. Now similarly, if we will put down the value of n equals to 1 in this recurrence relation, and if we will simplify the result, you will be having the value of a2, and that will be in terms of a1. And here you have to replace a1 by minus 1 by 6 a0. So you will be getting the value of a2 in terms of a0, that is 1 over 120 into a0. Okay, now substituting r equals to 1 by 2 and values of a1 a2 in equation number 2, and equation number 2 is x raised to r into bracket a0 plus a1x plus a2x square. Okay, so y2 equals to x raised to r, and the value of r is 1 by 2 into bracket a0 plus value of a1, that is minus a0 by 6 into x, plus value of a2, that is 1 over 120 a0 x square and so on. Okay, now x raised to 1 by 2, that is root x, and taking a0 common, so into bracket we have 1 minus x by 6 plus x square by 120 and so on. So this is y2. Now the general solution is given by this formula, that is y equals to c1 y1 plus c2 y2. So c1 will be as it is, y1 is this one, okay, plus c2 will be as it is, and y2 is this one. Now consider c1 a0, that is equals to a. So replacing c1 a0 by a, and this is nothing but the Maclaurin series of cosine of root x. So we are replacing this series by cosine of root x. And then after, consider C2A0 as b. So replacing C2A0 by b, and if we will multiply root x by all the three terms and so on, you will be getting the Maclaurin series of sine root x. So replacing this whole term by sine root x. So y equals to a cos root x plus b sine root x, where a equals to c1a0 and b equals to c2a0 is the required series solution of the given differential equation. Thank you for watching this video.